So the last but not least, let's take a look at how to store our payload in a resource section. So again, we go to our resources, course resources or materials, implement resources, and let's take a look at the source code. So there are two main differences from what we have seen so far. This part of code we already know. So this is our virtual alloc, copying memory, changing protection, and launching our payload as a thread. So that no change here. The two differences are here actually. So first of all, you might have noticed that we don't have any payload here. I mean, there is no global variable or local variable which is initialized with our payload. It's only declared here. So that's the first difference. The second difference is the source of our payload, which is resources actually. So our payload is initialized using these three functions. And so let's go through them. Find resource goes out and asks the system to locate this resource in our PE file. Okay, so it says like, hey system, give me favicon resource from my PE file. Okay, and it will return a handle to something which is called resource information block. And this handle is then used by load resource, which returns another handle, and this time is a handle to a module containing our resource. Okay, and this the second handle is actually used to return the pointer to the first byte of our payload or in our resource. But in our case, our resource is at the same time is our payload. Okay, so lock resource returns an address to our payload, and it will be stored in a payload variable. And the last function also returns the size of our resource / payload, and it will be stored in this variable. Okay. Now, what is this? I mean, favicon. Actually, it is defined as a number, but declared as this this name. But first, let's take a look at compile batch. So it is a slightly different from what we have seen previously. So what we do is we take a resource RC file, okay, which is here. Let's open it. And resource.rc file defines that favicon is a type of RC data, and all the data is stored in calc.ico file, okay, which is here. And this file contains a shellcode which will launch a calc exe. So this is a very simple payload generated from a Metasploit framework. Okay, you can view it here, but it's in binary form, so it's just a garbage. The only thing you can see here is the calc.exe at the end. Let's take a look at resources.h, the header file. And the header file is just a definition of favicon name, which is just a number, which is 100. Okay, so if we go back to here, it all means that our resource is identified by a number 100, and this flow of calls will retrieve our payload from resources. Okay, so RC is a resource compiler, and it will take RC file, so this definition, and it will create a file which is of type Windows resource, and this Windows resource file will then be used by the resource converter, which will convert this type of file into an object file, because we need that object file to then be understandable by our C compiler when it will link our program into final PE file, which is implant.exe. So in other words, this converter converts our resource file into an object file containing our shellcode, okay, and then C compiler compile our dropper, producing an implant.exe, but it will also include our object file, which contains our payload. Okay, so let's compile it. So we go to our resources 0203, we run compile, and let's run it. But before we will run it, let's attach our debugger to see what is happening inside. Okay, so first of all, let's take a look where these addresses are located. So memory map, and so the first address is this one, and it's our payload, which again, payload points to somewhere in the resources section. So we can check the resources section is this one, and if you check the address is A2, yeah, the offset is 60. So it is somewhere pointing somewhere into the resources section. The second address is what we have allocated with virtual alloc. Yeah, this is exec memory, and this buffer points to, where is it? It has to be something like this one. Let's verify. F8. Yes, this is this one. So what we can do, we can actually also view that in our debugger. So let's go to CPU tab, and in a dump, let's go to expression, right click, paste, and here is our shellcode. Okay, at the end you can see the calc.exe. So this address is in the resources section. Now let's take the second address, go to dump number 2, and again go to expression, and as you can see, it's completely identical. So now this buffer, which is allocated here, okay, it's our executable buffer, will be executed when we run our program. So we can actually see that happening. So let's click on a CPU window, and let's again go to expression, paste, and so here is our shellcode, again our calc shellcode. And now let's set a breakpoint here. So F2 or just toggle. We run the program, it's running, and now it waits for us to waits for a key to be hit. So let's hit enter, and as you can see, the process stopped and our breakpoint was hit. So let's remove the breakpoint again. Breakpoint F2 and run it again, and if all goes well, the calc should pop up. And again, we are now in our payload, so it will get executed right now. Okay, so let's hit enter, let's hit F9 or run, and our calc is here. Okay, it has popped up and the program exited. So this is how you can run you can store your payload in a resource file. If you want to use this template, again, what you need to do is remove printfs, get car, and put your payload in a binary format into calc.ico file. Okay, and then you should be good to go. So this concludes this part of our course, and we will next discuss how to encrypt and encode our payloads in our dropper.